All right, algebra students, we have notes for 8-4, recursive sequences, focusing on evaluating. So out of the next two lessons that deal with these recursive sequences, this one is the most important one. It will show up on your Regents exam in one form of a question, like one multiple choice or one 2-point question. So a couple of things we need to rearrange here. Sequences can be, instead of defined, I want to change that to written. Defined is fine also, but written I just like better. Sequences can be written using a variety of methods, such as we've looked at things like function notation, right, with that A of n. We're just gonna ignore that. Or instead of function notation, we were looking at more recently sequence notation. So you can write them with either sequence or function notation. Remember, sequence being that A sub n notation. So those are the two different ways you can write them, function or sequence notation. They can be defined, they as in sequences, can be defined with an explicitly, or what's called recursively. Explicit, when you hear that word explicitly, there should be an ly there, explicitly, that is talking about a regular normal equation. And that normal equation can be written either in function or sequence notation. And recursive, we're going to learn, and we're going to talk about that one right now. A recursive sequence, and remember that a sequence is just a straight up a list of numbers, an ordered list of numbers, right? Focusing on those whole number points. So a recursive sequence is just a sequence that is written such that each term depends on the term or terms, could be more than one, before it. It talks about that quote unquote previous term. So if we're looking at, if we're starting with A sub n, the term before A sub n, well, the term after A sub 1 n would be A sub n minus 1. The term before that would be A sub n minus 1. A sub n minus 1 is that previous term. Sorry, I'm dying. Okay, so when we're looking at these cursive definitions or these sequences, remember you are given these two formulas on your reference sheet. You just need to look them up. So basically these two formulas, one of these is an arithmetic one is a geometric. You can see that the D one here is going to be my arithmetic, because that D represents that common difference. And remember, we know that arithmetic equations are just different forms of linear equations. And we know that every single linear equation has some sort of the form of y equals mx plus b. That's exactly what this this formula here is really doing, basically. This is still just like a y equals, except that's my b. Remember, d is my slope, and instead of x, we're using n. So still a y equals, b plus xm, still mx plus b, just different pieces or just different names. Here, this one would be our geometric sequence because, again, you can see that R representing that common ratio or that multiplying factor. And per usual, every single one of these is just like a y equals ax times is just like a y equals a times b raised to the x power, right? That y equals that initial starting value, my multiplying factor, raised to that x power. Just writing them with sequence in that subset notation. All right, you're going to get stuck when you're doing this a lot. The best information or the best advice I can give to you if you are stuck, you just need to plug something in to start. Sometimes just plugging something in will be enough to kind of trigger your brain to realize that, oh, I need to do this. Oh, okay, let's jump right in.